A chemical reaction is a change that occurs between two or more substances that create a new substance with a different chemical composition. During a chemical reaction, energy can be released, such as in a firework or a bomb, or absorbed, as can be seen in ice packs.
Chemical reactions and the products they form are essential to our everyday lives. For example, photosynthesis is a chemical reaction that occurs in plants. This reaction takes place when carbon dioxide and water react with the light energy from the sun to form glucose and oxygen. The two products created by this reaction are essential for human life.
A phase change is not a chemical reaction. When water freezes to form ice, it changes from a liquid to a solid. However, the chemical formula for water, H2O, has not been changed, and therefore a chemical reaction has not occurred.
In chemistry, we use chemical equations to represent the changes that occur in a chemical reaction. For example, if we take another look at photosynthesis, the chemical reaction that we saw earlier, and write it down on paper, it looks something like this.
The reactants are the substances to the left of the arrow, CO2, H2O, and light. The products are the substances to the right of the arrow, C6, H12O6, and O2. The numbers in front of the reactants and products are called coefficients. Coefficients tell us how many of each type of molecules there are in the equation. The letters in parentheses after each molecule represent the state of the product or reactant.
A substance can either be a gas, a liquid, a solid, or aqueous, meaning that it is dissolved in water.
The arrow in between the reactants and products represent a chemical reaction occurring. It can be read as yields. This is how we read the chemical equation aloud. 6 molecules of gaseous carbon dioxide react with 6 molecules of water in the presence of light to yield aqueous glucose and 6 molecules of gaseous oxygen.
Is this equation balanced? The answer is no. If we count the number of atoms of magnesium and oxygen on the reactant side, they should equal the number of atoms of magnesium and oxygen on the product side. The difference here is that there are 2 oxygen atoms in the reactants and only 1 oxygen atom in the products. To balance the equation, we must use coefficients so that there are 2 oxygen atoms on the product side. Let's count the atoms again. This equation is still not balanced. Remember, according to Mr. and Mrs. Lavoisier, matter is neither created nor destroyed in a chemical reaction. In other words, there should be no new reactants or products in the equation, and the chemical formulas of the substances should never change. Only the coefficients should change. There are 5 different classes of chemical reactions that are important to understand. Oxidation-reduction reactions. Hydrogenation. Hydrolysis. Hydration. Dehydration. There is a change in color. A solid, or a precipitate, is formed. A gas is formed. There is a raise in temperature, or appearance of flames. Light is given off.